Alright, so for this lesson, we're going to talk about sex. So, sex and gender are going to be two different things. Sex is usually something defined by biology, but doesn't necessarily have to be. But for the sake of our class, we are going to be defining it in terms of biology. So, typically in humans, we define sex based on phenotypic differences. And these are what you've often heard of. These are our secondary sex characteristics. So 2', that's another way of writing secondary. So these are some things that you're familiar with. So we have things like genitalia, where males have a penis and females have a vagina. We also have muscle mass. Typically, although a lot of these are sometimes overlapping, which is why it's not necessarily a good way of defining sex, but this is typically, if you were to look on a scale, on average, males will have more muscle mass than females. We also have body fat distribution. So typically in males, you find fat distribution is primarily in an abdominal region, sort of around here. In women, it's typically in the femoral region and the thighs and hips and in the pectoral region. And then we also have body hair. Both the amount and the distribution. So males typically will have more body hair than females, and its distribution will be a little bit different. Both sexes will have body hair in our genital regions, typically in our armpit regions. What's the fancy word for that? I'm forgetting right now. But males will also then typically have more body hair on their pectoral region as well as in their facial region. So these are what we typically define the two different sexes are. But as we say, there are definitely distributions of these that are overlapping, so these are by no means definitive. Other things that can help us to determine sex, and this doesn't apply to just humans, but also the environment plays a role as well as our genetic information. And we're just now learning a lot of the differences between these two things. But for some organisms, environment is the more critical component. And in other organisms, the chromosomes are more typical. And this can be seen in figure 710. For animals like reptiles, which include alligators and turtles, actually the environment plays more of a role. The temperature that the eggs are incubated at will determine the sex. And as you can see for alligators and turtles, it's actually opposite. Both of these organisms build a hole in the ground, they lay their eggs, and then they cover over the eggs. So if you're cooler for one species, you'll be female. If you're cooler for the other, you'll be male, and vice versa. So those eggs that are on the top or the bottom will matter, because those that are in the bottom will typically be warmer because they'll have a constant temperature of the ground, whereas those on the top, because they're closer to the surface, will fluctuate depending on the air temperature. And then other organisms, like humans, chromosomes play the greater role. It's not to say that environment doesn't play a role here. It doesn't say that chromosomes don't play a role here. This is just the major portion. Insects, chromosomes are definitely more important. So they show you a grasshopper. For instance, in flies, actually, flies have a similar system to humans. They have an XY system as well, but it turns out that for flies, XX is male and XY is female. And then also birds. So they show a chicken, a rooster, and for birds, chromosomes play more of an important role than the environment. And this is interesting also evolutionarily if you think about it, because birds are the descendants of reptiles. So over time, this lineage has changed from environment being more important to determining sex to a chromosomal system being more important for sex. And then one other thing we want to know about sex determination is more about how the ratios of male and females change over time. So if we recall, if you have a mom and a dad and they have a kid, remember mom has two X chromosomes, non-disjunction not being applicable. If we were to then look at the Punnett square of determining sex, we would see that upon fertilization, we would expect a 50-50 ratio because dad has a 50% chance of giving the X and a 50% chance of giving the Y. However, it turns out that there does seem to be some kind of bias, and we don't necessarily know why there's this bias, but there definitely seems to be some kind of bias because at fertilization, the ratio of males to females is actually a little bit higher for males. And like I say, we really don't know why this is there, but it's definitely significantly different from 1-to-1. We just saw in the Punnett square, hypothetically, we would expect a 1-to-1 ratio, but we actually see that upon fertilization, it's really a little bit higher for males. Now, as males and females come to puberty and begin adulthood, all of a sudden this ratio shifts and does finally become about 1-to-1. So we think the biggest reason for this is accidents. And by accidents, we generally mean a typical male is generally more adventurous than a typical female. That's a generalization, does not apply to every individual. I know there are more females that are sometimes more explorative, but in general, behaviorally, young boys are a little bit more risky than females are, which leads to more accidents. So that while we have this imbalance at fertilization, by the time we get to beginning of adulthood, 15 to 20, boys have done more things, more accidents, made stupid decisions. And we see this in general because why do men pay more for insurance early on in life than women? Because they're generally riskier drivers. So more boys end up taking themselves out of the gene pool by the time they reach adulthood. And then once we do get into adulthood and beyond, we see the scale tip back. So there's no exact number once you get, so this is when we say beginning adulthood, this means somewhere between 15 and 20. And here we're talking about 35 years or older. We definitely begin to see the demographics change, and there are more women to men. So like I say, there's no definitive ratio like we had here, but we know it is greater than 1, and it becomes significantly different. And this is one of the hypotheses we did early on in the semester. I showed you a chi-square analysis where more women are being affected by COVID. Well, if you have a greater ratio of women to men, you by statistics are therefore, even if the disease is affecting everyone equally, you would still end up with more women with the disease just because there are more women out there.